Yeah, we have B. Many has, Dr. Sandhu has said B, Adriana says B, said B. So let's check the result. Uh, so yes, the final answer is B. Why? Because EHR systems are used for routine patient care. They store clinical information for everyday data. So the correct answer for this portion is B. Moving on to the next portion, module 2, relational database and SQL basics. So we're not gonna go over much to SQL basis. These are just for example. So in this module, we're gonna learn how data is organized and how we should select and query the data that we require for our use. There can be in a data set, in a database, there can be millions of data point, and we do not need everything, because if we try to use all of the data, that will slow down our machine, right? So we don't want that. We definitely want an efficient machine, so that we can work efficiently. So in this segment, just think of, we have three tables. In one table, we have just subjects. One table name is subject, and another one is vitals, and then adverse events. In these tables, we have columns, or as we discussed earlier, we have fields like subject ID, which is the unique ID. You can think of this as a primary key. The unique ID is unique for all of the patients, and then site, enroll date, treatment arm, and then these are the fields of subjects table. And then we have vitals, where we have columns, we have variables like subject ID, visit number, blood pressure, then heart rate. These are the columns of vitals tables. And adverse events, we have columns like event name, severity, and start date, and also the subject ID. So how we are connecting these tables using this unique ID, the subject ID. We're connecting our tables using this subject ID. So subject ID says subject ID of one subject table is similar to subject ID of vital table, also similar to subject ID of adverse events. When we connect using this, when you connect all these three tables using this unique ID, we can use all this data set, and we know that the, for this unique ID, all these data points are valid. So and this is also very beneficial in a way that we don't have to pull all the data set every time. Suppose you want to find a mean. When you are trying to find a mean from a data set, then you just need to find the mean for, suppose, visit number or blood pressure. Then you don't need to run all those columns, all these other 9 columns. You just need to run one column. So you just pick using this unique key. You just pick blood pressure ID, blood pressure measurements, and then find the mean. This way, it is time efficient. Also, this saves the machine from doing a lot of work, and it is also in terms of capacity, it takes less space. Then these are some examples of how we can utilize SQL to get some get some information from a table or from a bunch of tables. So in SQL, if in plain language, if I want to know, show me the name on blood pressure of all patients whose blood pressure is above 140. So we can write some condition using these database management tools. So I want to know that the patient's name and blood pressure of the patients whose blood pressure is above 140. So I'll just select the column that I need, select the columns. So I require these two columns, and from which table? From the vital tables. And then I'm going to create a condition where is the condition? Then I'm going to write the variable name greater than 140. So this will allow me to see, if I run it, this will allow me to see patients who has blood pressure more than 140. The same way, the next one, in in a simple language, we can say what is the average blood pressure in each treatment group. So in each treatment group, so we're going to group the treatment groups. Then we're going to find out the average. As you can see in the first line, I did average of the column of that variable blood pressure. So this will give me the mean of, and first this will create cohort by treatment, and for each cohort, what is the mean blood pressure. So, and the third one says show me patient names alongside their blood pressure readings by linking both tables. So we are joining two tables. So join, there are two tables that we are joining, uh, and by what we are joining. We are joining using subject ID, that means the unique ID that we had from both of these tables. So this is how we can join tables. We can use a simple small table when we need, and we can use a complicated one when we need it that way. So it actually depends on what kind of analysis, of what kind of query we are searching for. Moving on from here, uh, we have another knowledge check question for module 2. In a clinical trial database, the vitals table contains a column called subject ID that links each vital sign reading to the correct patient in the subject tables. What is the subject ID called in the vital tables? Is it a primary key? Is it a foreign key? Is it a metadata? Is it a variable label? So what is a variable label? Variable label is the column name, right? So blood pressure can be a variable label. Then metadata tells us about the information about the data. Then foreign key is, so foreign key is also a unique key, but when you are connecting two tables, the other table unique key is foreign key. So in this case, as Dr. Sandhu mentioned, our subject ID here is the primary key, so because this is a unique key, and we are using this primary key to join tables, to join different tables. Oh, sorry, this is a foreign key because this is also a unique key, but foreign key as of this is the foreign table. This is the other table. Suppose we are joining two tables, table A and table B. Table A is primary key, table B is foreign key. But these both are the same. Both are the same keys. As you can see, our main table was subject tables, and we are talking about vital tables. So this subject ID here is the foreign key, and subject ID on the subject table is the primary key. Moving on from there, on our third module, we are going to talk about data quality. Data quality in terms of keeping clinical data clean, accurate, and trustworthy. So there are some protocol that we have to follow to keep the cleanliness of our data. So uh, I have so here are 6 qualities every clinical data set should have. So starting with completeness, meaning we have to make sure we have enough data points, that the missing values does not influence our data, influence our findings. So all required fields must be filled in. If more than 5% of a key variable is missing, this is typically flagged as a quality concern by the CDISC guidelines, but note not applicable is different from missing. Suppose something we have, suppose we have, just think of we have a conditional question like if you're female, gender, if someone is female or male. If someone is female, they can also have a pregnancy test. So that is a conditional situation. So for male, the second condition after the condition, the answer would be not applicable, right? So a scenario like that is not treated as missing values. Those are not applicable. So then we have accuracy. Values, accuracy, the recorded value must match the true clinical measurements. This can be verified by source data verification. A monitor physically checks the database entry against the original medical record or paper CRF. Then consistency. There should be no internal contradictions. Classical examples that actually appear in clinical trial data. A patient's recorded death date is before their date of birth, which is unrealistic. We cannot have a situation like that. Then timeliness. Data should be entered within the protocol specific time window. If a study protocol says data must be entered within 48 hours of a visit and it is entered a week later, this is a timeliness violation. For time sensitive endpoints, late entry can affect validity. Then uniqueness. Every patient should appear exactly once in a master table. So remember, in our subject ID table, that was the master table, and every unique ID, subject ID, should appear once, just once. I cannot have two people with same unique ID. That will have a problem of duplicacy, and also if we are measuring something, we will double count the measurement. So we have to make sure there is uniqueness in your data points. And then validity. Values must be within realistic range. A heart rate of 400 bpb, hemoglobin of 50 gram per dl, and age of, suppose someone's age is negative. Nobody can have a negative age. So we have to make sure that the data is valid. In the next slide, we have how can we catch errors. For rain check, we can have age entered as 185 as flagged, catches values outside realistic limits, as I was talking about the information in the past slide. Then we have format check ensures data is in the correct structure. A date entered as, suppose we can have different date format, right? We have to make sure that the date format is similar for all the data. Um, then completeness check, flux required fields that are empty. So if there are some empty unique IDs, we have to be aware of that, because if unique ID is empty, we cannot find the person whose data we have created or we have collected.
What I say?
So
I'm sorry.
Fikil, you're muted. I don't know if that's on purpose.
This should be. Can you hear me?
Yes, we can hear you, Elvin.
Okay. Okay. All right. Sorry for the interruption. We're gonna continue. And I guess you can see my screen also, right?
Yeah.
Okay. All right. All right. Nice. Nice. Sorry for the interruption. We're gonna keep going from here. Okay. So as I was talking about, the cross form checks. Yeah. Where is? Um,
No, we can't hear him now, Elvin.
I guess I see what's going on here. Hello? Yeah, it's good now because there was another one. Yeah. So cross-form checks. So yeah, cross-form checks. These compares data across different forms. A pregnancy test results of positive for a participant recorded as male on the demographics from should trigger a query. In the next segment, we have again next segment we have a question. A data entry coordinator enters a patient's age as 185 years. Which type of edit check would automatically flag this as an error? I would appreciate if you all can participate and write your answer in the chat box. We have answers like B, C. Let's see. It seems like this is a range check. Let's see. Let's check out. Yes, this is a range check because a person cannot have age. Person cannot have age 185. That is very unrealistic. I mean, one can have age 185, but so far it's very unrealistic. Now, moving on to the next module, we have RedCap and electronic data capture. So this is the tools that is widely used in uh, in healthcare industry, and RedCap stands for Research Electronic Data Capture. It was developed at Vanderbilt University and made freely available to academic institutions. If your university has a research IT or clinical trial unit, they almost certainly have RedCap installation in your access. So why should we use RedCap? It is because of easy. This is easy to build, and you design your data collection forms using a drag and drop interface. You do not need to write any code. You choose the field types, text box, number, date, multiple choice, checkbox, add any violation rules, and publish the form. Then it has branching logic, as we were talking about. If a person um, gender, male or female, only only a branching logic can work here, as the next question can be if the person can be pregnant or not. So, then we can only have female. We can only have female participants, as male cannot be pregnant. So it also has branching logic, then built-in validation. As you design each field, you set the allowed values and formats. When a coordinator enters data, the system immediately flags anything that violates these rules. Then it is easy to export so when your study is done, you click a button and RedCap exports your data directly to Excel, SPSS, or SAS or Stata with variable labels and value codes already applied. This saves hours of data preparation. Then then secure and compliant. RedCap meets HIPAA security requirements, which is really good. And we have then double entry, double data entry check. Two people enter the same data independently. The system flags any differences to catch typos. So we have another knowledge check here. In RedCap, a researcher wants to question, are you currently breastfeeding? To appear only when the participant answers female to the gender question. Which RedCap feature makes it possible? Let me know, best of your knowledge. Can it be a double entry, double data entry, data access groups, branching logic, API integration? What it can be? I can see a lot of answers from C, branching logic. Yes, you're right. This can be a situation, this can be a RedCap branching logic feature that can actually catch this type of uh, incorrectness. So branching logic, also called skip logic or conditional display, shows or hides fields based on previous answers. Double data entry is for catching typos by having two people entering the same data, as we discussed, and data access group control users permission from managers or from upper authorities. Then we have data standards and CDISC regulations. To begin with, so just imagine if all the hospitals, if they have their own, uh, if they had their own language to collect the format for blood pressure readings, then it would be very, I mean, for a person who will study those blood pressure readings outside of that hospital, will have to learn a new thing every time he or she uh, encounter a situation like this. So uh, there is a universal language of clinical data, which is CDISC, and just as medical professionals worldwide use the same anatomical terminology, CDISC gives data managers and biostatisticians a shared vocabulary and structure. So um, there are 4 CDISC standards that you need to know, and we're going to talk about this clinical data acquisition standards harmonization, which tells you to how to design your data collection forms. It specifies what fields to include on your CRF and what to name them. If you follow CDAHS SH when building your RedCap forms, the data you collect will map neatly onto SDTM later, which is the next step, study data tabulation model. So study data tabulation model, uh, um, once the data is collected, it helps to organize the data. So in that way, it is really helpful, because if we have a data set that is not organized, it won't be easy to use those data sets. And every time we encounter these databases, we have to figure out how to get the best out of it. Then we have analysis data model. The analysis layer, uh, SDTM data is then transformed into AADM, which is the analysis data model. And these are specifically designed for statistical analysis. The most important analysis data model is ADSL, 1 row per subject, which is the backbone of most analysis. So in each row we have one patient. To simply put it, this is we can put it in a simplest way. So in each row we have one patient. In each row we have one patient's unique ID, name, their weight, insurance, their BP, whatever disease they're facing. We are trying to trying to work with. So that's all information should be in one row. And then operational data model. Uh, so operational data model is an XML file format used to move data safely between systems. It is kind of an envelope that wraps your data for electronic transfer. Then again, we have a knowledge check. A biostatistician is preparing the final data sets for a FDA drug submission. These data sets are derived from the raw data and are used directly in the statistical analysis, which CDISC model describes this data set. So we have options like CDAHS, SDTM, ADAM, which is the analysis part, and ODM, which is the file transfer format. So what should we use? It seems like uh, we are in the data analysis. Uh, so we already have our data, raw data, and it has been organized, right? So it has been organized. So we are in the phase of data analysis. So after collected the raw data, we organize the raw data in SDTM, then we do the analysis. So for our question, we were in the phase of statistical analysis. So uh, we do the analysis data model. Then in our sixth module, we have privacy and compliance, protecting patients and following the rules. So we have HIPAA, GPC for our privacy compliance, HIPAA, the Health Insurance Portability and Accountability Act, governs patients' privacy in the United States. The core concept for researcher is de-identification. If you want to share patient data for research without getting individual consent, you must remove 18 specific types of identifiers like social security, your name, information that can be traced back to you easily. This includes obvious ones like, as I was telling, um, uh, names, addresses, social security number, but also less obvious ones like all dates, more specific than year. Suppose um, someone was born on 11th November 1998, then we can use only the year, not the specific dates or months. That will be a HIPAA violation. Their zip codes, phone numbers, email addresses, because nowadays this can be used to send you spam calls, spam emails. So we have to make sure also the medical records. There can be a lot of misuse with the medical records. Then for GCP, which is good clinical practices, and good clinical practice is the international ethical and scientific quality standard for clinical trials defined by uh, ICH E6. Two principles are particularly important for data management. First, source data must be original, legible and accurate, and recorded at the time of the observation. If a nurse takes a blood pressure reading, it should be entered into the database that day, not reconstruction from memory or week later. Second, every changes every changes that we make on our data must be documented with who made the changes, when, and why. The audit trail captures all of this automatically in a well-designed EDC system. So the main mantra for GCP is, if it was not documented, it never happened. So if it is not documented, it did not happen. Moving on to the next slide, we have knowledge check again. According to good clinical practice, if a data manager needs to correct an error in a patient record after it has been entered, what must they do? There are four options: delete the original entry and retype the correct value, then correct the value and document the change with the reason, date, and their initials. List. Number C, leave the error and note it verbally to the supervisor. Number D says, ask the patient to sign a new consent form before any correction. What should be the answer? What should be the correct answer? I can see many in the chat box have mentioned B. Let's check. B says correct the value and document the value and document the change with a reason, date, and their initials, which is the correct answer. As GCP requires a complete and transparent audit trail, every correction must preserve the original value, and the new value must be accompanied by who made the change, why, and when. In our next module, we're going to talk about preparing data analysis. And in this portion, we already have a whole workshop about data analysis, but we're going to go briefly about few things like data profiling. Before touching the data analytically, we explore it descriptively, meaning see stuff like 5 number summaries, how the data is distributed, if it is skewed or not, how many records are there, looking into the graphs, how many records are there, and among those records, how many are missing, what percentage of each variable is missing, what are the minimum and maximum value, and what are there any unexpected values, like as we're talking about something range out, something that is outside of the range, extreme values, outliers. So then we have missing data strategy. How can we take care of those missing data? Because if we have too many missing data, that will bend our analysis, that will create skewness. So we have to make sure that we handle our missing values. So uh, we are going to later cover 3 types of missing values in detail, but in this one, I can tell that if something, if we can keep the missing values as it is sometime, as I mentioned, sometimes missing values means just not applicable, but sometimes we have to do imputation. We have to fill up those missing values using different kinds of imputation, data imputation like mean, median, or sometime using random number generation from a distribution. So, and then we have derived variables. What are derived variables? Derived variables are something we have. Suppose think of a profit column. Column requires uh, profit column requires revenue column and expenditure column. So those expenditure and revenue are used to create this profit column. So we have used some formula to derive some variables. And another example can be BMI body mass index from height to weight, changes from baseline, clearly defined, every formula that is used. Then final export and check, label all variables and value codes. Value codes meaning we have to decode our variables. Like if uh, we have a gender like male and female, we can decode that as 1, 2, or 0, 1, however it fits. Then export it in the correct format, comma separated format that is used in SAS or R. R can take different format, Excel format, CSV format, different format, and then validate against the analysis plan. So we have come up with a question when we started this. So we have to make sure that our data that we have collected or the previous steps that we have endured has a true connection with our data analysis plan, which will answer our final question. Then archive all documentation. Then I was talking about that we are going to talk a few types of missing values. Here we have a few types of missing values. MCAR, which is missing completely at random. So what is missing completely at random? So a lab sample is accidentally spilled, but we still have some sample, and definitely uh, we can definitely complete our testing. So suppose we have 2 ml of lab sample and 1 ml has spilled. So we can use definitely another 1 ml would be sufficient to do the testing. So this loss, this is least problematic, and we can usually use the remaining data. Then MAR, missing at random. Older patients miss more follow-ups visits, but their clinical status does not affect who is missing. So this is manageable. Use statistical method like multiple imputation can help us with this problem. And then the last one is missing, not at random. Patient drops out because they are getting worse. So the sickest patient have missing outcome data. This is the most serious one, and this is the most serious one, and probability of data being missing is directly related to the uh, value that this is missing. It requires spatial analysis and sensitivity testing. Then we have in the next slide another uh, portion, another knowledge check. In a clinical trial, patients who are getting sicker are more likely to drop out, leaving their outcome data missing. This pattern of missing data is classified as which one? Complete case missing, missing not at random, missing at random, missing completely at random. Dr. Sandhu says C, and we have like 5 minutes. We're gonna pace up from here. So the answer is yes, number C, missing not at random. So missing not at random occurs when the reason data is missing is directly related to the missing value itself. Here, the sticker patient with worse outcome are the why ones dropping out. This is the most serious type of missing because simply removing those patients would bias the results toward making the treatment look better than it is. Then in our last segment, we have database lock and archiving, how we can archive our data and what are the ways that we can do it and what are the regulation. We're going to go over with this. So before lock, we have to go over some checklist. So the database lock is a major milestone in any clinical trial. Once locked, the data is frozen. No corrections, no additions, no changes of any kind without going through a formal unlock process, which itself requires a full documentation. So here we have all forms completed and verified against source documents, all data queries resolved, no outstanding errors, medical coding for adverse events, medication. We have to decode all the information that can be critical, date reviewed, and make sure that the dates are in similar format and approved by the manager. And at the end, biostatistician confirms data is ready for analysis. And after lockup, how long how long are we going to keep it? 15 years after trial ends. This is the FDA requirement. And then we have to make sure what are the database and audit trials, analysis plan, training records, the format of the data, uh, comma separated value, PDF or paper, both are acceptable, and then access. In terms of access, who can access it must be retrievable within 48 hours of inspection. And when can we destroy it? Only with sponsors approval and full documentation. Then we have our last knowledge check. According to FDA regulation, how long must clinical trial data record be kept after the trial is completed? We just talked about it at the beginning of last slide. As everyone is saying, number D. Number D is 15 years as the FDA regulation, number D. Then in our last slide, this is the wrapping slide. We're going to wrap this. This is the last slide. We're going to wrap it up. So there are some key takeaways that we should remember. First is design the database before collecting the data. Make sure we plan it accordingly. Then data quality like completeness, accuracy. Then there are more other things, looking for missing values, looking for valid data. Document every decision. If we change something after we record it, we have to make sure why we changed it, uh, when we changed it, and who did it. Then we have to follow the CDISC standards form from the start, and retrofitting is can be costly. Define the analysis before looking at unblinded data. Audit trials are not optional. Every change must be traceable. As I was mentioning, missing data has a mechanism. We have to understand it, why they are missing, and how should we deal with it. And at the end, we have to make sure of the privacy and security for the protection of the patients. Uh, this is the end of our segment today. Thank you so much. Thank you, everybody, for joining us. Thank you, Dr. Sandhu. Thank you for joining us. Let me know if you have any question. I'll be happy to answer them.